Hello and welcome to the Fossil Huntress podcast. Today we're going to be talking about the Rocky Mountain Trench, or the Valley of 1,000 Peaks, which is one of those few and huge geologic features that can be seen from space. The Rocky Mountain Trench is a series of valleys that primarily a product of geologic faulting and pushing and pulling. We see some in their original V shape and others have been scraped into a U shape by the glaciers. The trench separates the Rocky Mountains on its eastern side from the Columbia Mountains and Cassiar Mountains in the west. And this truly is one of the few geologic features we can see from space, but it's also super handy if you're flying a plane north to south, because it's a really clear and easy feature to see. The southern section of the Rocky Mountain Trench, which runs up from Montana into eastern British Columbia, all the way to about our halfway mark in Prince George, was created when the Earth's crust stretched across BC and broke along a huge fault line about 45 million years ago. The northern section of the Rocky Mountain Trench begins just above Prince George. So Prince George is, in my mind's eye, kind of the halfway point north to south in BC. And so from just north of Prince George, north again, all the way up to the Liard River, which is just on the BC-Yukon border, the faulting, which is a different faulting system, pushed the other way. So while the southern section of the trench pushed south, this western section of the trench pushed north. Picture a tug-of-war. So everywhere in the world, we get big ugly brutes on one side of a rope and the other, and maybe put a pond of mud or a active fire between them, and they push and they pull. Very similar to what was going on in the San Andreas Fault in California. And this pushing and pulling back and forth created a rift and created these big valleys that we can now see from space. That faulting and pushing and pulling went on for about 140 million years. So we see some push me, pull me north-south and some lateral movement across the margin of that ancient North America. And this was during the time that BC was forming. So we had all these volcanic island terrains, much like the Philippines, erupting and pushing and pulling and riding the undersea Pacific plate, slamming obliquely into the west coast of North America. And so while that initial process of land building or sliding and colliding started about 170 million years ago, back in the Jurassic, it was about 140 million years of geologic push-pull that created the trench. I want you to imagine the British Columbia coast at this time, or the more North American coast, being like a book. And you want to stuff a wedge in there and peel off the top layers. So the continent was doing just that. It acted like a wedge, peeling the lighter rock of the volcanic islands off the underlying oceanic plate and adding them to its already enormous territory. So during this time, inland from the collision zone, the new territory, this new Earth, was being used as a bulldozer. So rumpling the sedimentary layers northeast, it created the first Columbia Mountains and then the western part of the Rockies. When this was happening, the two mountain ranges were one. The Rocky Mountain Trench had not yet formed to divide them. But out in the growing mountain range was a trough in the Earth's crust, fringing it with thick swamps, muddy deltas, and shallow bays, and home to many species of dinosaurs. The time and pressure transformed these ancient swamps into some of the most beautiful and bountiful cold fields, and today they stretch from southeast of Fernie to north of Sparwood and into the Crow's Nest Pass. So time moved on and North America's relentless westward movement continued. About 85 million years ago, another series of volcanic islands began to crash into us as the coast mountains Vancouver Island, and Haida Gwaii were cemented onto the continental wedge. The pressure sent the Columbias and the main ranges of the Rockies soaring skyward, pushing them to heights comparable to today's Himalayas. And then the trough lying east of the ranges buckled upwards, raising the soft layers of sandstone, shale, and coal to form a long strip of hilly highlands lying at the elevation of about Tibet. Over time, erosion stripped these soft sediments away, exposing the hard layers that weathered into the front ranges of the Rockies. By about 55 million years ago, this pushing and pulling and all of the pressure on our continental coastline had eased up. And as the pressure was released, the land between the Columbia Mountains and the Rockies stretched. So picture a bunch of columns or a bunch of books in a bookcase. And so the books on the outside began to space apart, and those in the center, that big chunk of land, went straight down. And in a geeky way, that's a half graben block faulting, but it means that some space was made and that central section dropped down. And it's that section that we see now as the Rocky Mountain Trench. And that trench separated the Rockies on the eastern side from the Columbia Mountains on the west.